In the previous example, we discussed how the game needs to take input from an accelerometer, but then we realized that the accelerometer has an incompatible interface. It does not have the interface that the game expects. We know that the game expects an interface that contains up, down, left, and right methods, but the accelerometer contains only get horizontal axis and get vertical axis. So obviously, to reuse the functionality of accelerometer with the game, we will have to implement the adapter design pattern. So the first thing is to create an adapter class that will internally reuse the functionality of the accelerometer while providing a compatible interface to the game. So let's add a class. We will call this accel adapter and it will inherit from the input class. And now we have to decide how to reuse the functionality of the accelerometer in this class. As we discussed in the previous lectures, we can reuse the functionality through composition or inheritance. That is, the adapter can be a class adapter or an object adapter. So it is your choice to decide which one to use. But for now, let's reuse the functionality of the accelerometer through composition. So our accel adapter will be an object adapter. So we'll create an instance of accelerometer here. Now, how do we reuse the functionality of the accelerometer in these methods? We know that accelerometer contains two methods, get horizontal axis and get vertical axis. Get horizontal axis corresponds to the tilting of the phone in the horizontal direction, and get vertical axis corresponds to the tilting of the phone in the vertical direction. So this means we can use the values of get horizontal axis for turning the plane in left and right direction, and the values from get vertical axis can be used for changing the pitch of the plane. But you know that these return a double. In the implementation of these methods, we know that these methods return positive or negative value. So for horizontal axis, if the phone is tilted in the left direction, it will return a negative value. And if the phone is tilted in the right direction, it will return a positive value. So we can use these values like this. So for left and right, we will simply get the horizontal axis, and if the horizontal axis is less than 0, then it means the phone is being tilted in the left direction. And then this expression will return true. And that's exactly what we want. And we can use the same thing in the call to the right method, except that here we have to check if the value is positive. If the value is positive, then right will return true. And we'll do the same thing for up and down. That's it. We are done with our implementation. Now let's use the adapter with our game. Now instead of creating instance of the keyboard, because we want to use the accelerometer, we will create instance of the accel adapter. And this is the output. To make sense of this output, let's display some helper messages in the accelerometer class. So what I want is to know what values have been generated. Now let's run again. Let's try to make sense of this output. Now here you see we are first checking for the up key, and up will internally call get vertical axis. And since that returned a negative value, up will return false. And then it will go to down, and down will again call get vertical axis, and it returns a positive value. And for positive value in down, this indicates it will return false. So both up and down are going to return false. That's why it prints plane is level. And then for left, it will internally call get horizontal axis, and that returned a positive value. And if you remember, for left, it should have returned a negative value, and then only left would have returned true. But since it returned a positive value, left will return false. And then in right, it internally will call get horizontal axis, and that returns a positive value. And then we check. Since this is a positive value, right will return true. That is why it prints the message plane is turning right. So we have seen how we can use the adapter pattern to reuse an existing component that has an incompatible interface. The adapter that we implemented here is the object adapter. Let us see how these classes interact with each other through the class diagram. Axle adapter has an instance of the accelerometer. So accelerometer is the adaptee, and axle adapter is the adapter, and it is an object adapter. And here we have the client. And you can see the client can use the features of the accelerometer through axle adapter. So this way, even if you want to reuse a component with incompatible interface, you can still reuse it by creating an adapter for it. That's all for now. In the next video, we will see how to create the class adapter. Until then, goodbye.